Bonjour, everyone. My name is Karen Colbert. I'm the General Education Department Chair and Lead Math Faculty at Kiwanabe Ojibwe Community College. Today, we're going to do an overview of Section 1.4, Random Sampling and Experiments from the Carnegie Math Pathways Group Collaboration section. All right, let's say our faculty council is considering whether to offer a new Ojibwe language class in the evening instead of during the day. And they want to know what our students actually prefer, but they can't ask every single student. So the big question is, how do we gather student opinions fairly without missing voices that matter? In this video, we'll explore how statistics helps us answer questions like that, using sampling and experimentation techniques. But we'll also look at those tools through an Indigenous lens, because when it comes to research in our communities, how we gather data is just as important as what we do with it. So even though this is a video, take some time, go grab your notes, and let's dive into how some random sampling experiments can support decision-making in our community. Let's get started. Okay, so let's start with our first scenario. Let's suppose that our college is thinking about ways to raise money. And let's say somebody suggested, well, what if we offered reserved parking spots for $100? That's a good way to raise money, and we could raise it fast. But first, we might want to know, would the students even support this idea? Well, one idea is to just ask every student. This technique is called a census, which is a survey of the entire population. But here's the problem. Think of how often we take a census in the US. A census in the US is actually only done every 10 years, and it's a count of every single person. A census, it takes a lot of time, a lot of effort, and a lot of resources. And so imagine how difficult it would be tracking down every single student on our campus just to ask them a question. Some students don't check their emails regularly. Others aren't even on campus. So let's pause and think. Do you think there's a reasonable plan for our college? What might work better than doing a census? Let's walk through 3 possible ways that we could collect a sample. And as we go through each one of these cases, let's think, would this give a good picture of what students really think? So let's look at the first option. Choose 4 8 a.m. classes and survey every student in those classes. What do you think? Are these students different from those who only take classes at night? This is a common issue when you're doing a survey collection. I mean, we might be leaving out students who work during the day or have other obligations where they can't attend a morning class. So this method is actually called selection bias. So if we choose to do it this way, we're going to be leaving someone out. Let's look at another option. Another option is a website poll. So you put a poll on the college website and you use the students' responses of who responds. Now this sounds easy, but here's the issue. It's a voluntary response sample. So that means that people who feel strongly are actually more likely to respond than people who don't feel strongly. And this can actually skew your results. Now, finally, let's do an example where we talk to students who are coming in through the student center or our student services entrance. This is actually called a convenience sample. because it's actually based on who's nearby, not actually truly representative of the student population. So let's pause. None of these methods that we've talked about so far actually gives us what we're desiring, which is a representative sample. They all have some way of leaving voices out. So what's a better way? This is a map of the tribal colleges and universities in the US, and it represents more than 17,000 TCU students. So let's say that 13,000 of those students are on-campus students who would actually benefit from the parking lot. So if we had a list of every single student, all 13,000 of those students, and we assigned each one of the names of those students a number, 1 through 13,000, and then we randomly selected 150 of them. That's a simple random sample. And each person has the same chance or probability of being chosen. This type of sampling helps protect us from the selection bias that we had talked about before. It's not just good statistics, it's about being respectful of the entire student body. So when we're designing a study, it's not just about getting the answers, but it's about getting the right voices in the room. And that's not just good math, but that's also a good representation of Indigenous knowledge systems. In a previous unit, we discussed the 4-step process in a statistical study. The first step in the process is to ask a question that can be answered by collecting data. So in this collaboration, we're going to explore how an experiment can be used to answer a question. So imagine we want to know, does listening to music while studying change how much information you remember? So let's explore how to test this idea using an experiment. First, we need a hypothesis. A hypothesis is an informed guess about what we expect to happen. So here's a question for you. Do you think listening to music helps you remember more, less, or about the same as studying in complete silence? So write down your guess. So for example, you might hypothesize that listening to music while studying actually helps you remember way less because it's too much of a distraction. That's a good place to start. Or maybe you think that listening to music helps you remember more. Now that we have a hypothesis, we need to design an experiment to test it. Let's say we randomly assign 40 students to 2 groups. One group we'll call the control group. They study in complete silence, while the other is the treatment group. They listen to music while studying. Now remember, random assignment is key because it helps us ensure that both groups are as similar as possible apart from the treatment itself. This way, we're not unintentionally favoring one group over the other. So take a moment to think. Why is it important that every student has an equal chance of being in either group? Exactly. It minimizes other factors that might skew your results. So now, in our experiment, we have 2 key types of variables. The explanatory variable is the one we change. And so in this case, it's whether or not a student listens to music while studying. The response variable is what we measure, how much information the student remembers, maybe by using a quiz after studying. So let's break it down even further. The explanatory variable is whether they listen to music or not. The response variable could be their score on a quiz out of 10. So think about this. If one group scores noticeably higher on the quiz, can we say for sure that music was the cause? Or might there be other factors involved? Let's think on the importance of controlling for any other variables that might be the case. Now let's examine some sample data. So imagine the treatment group, the listening to music, has quiz scores like this: 5, 6, 4, 5, 4, 6, 5, 4, 3, 4. And the control group that listens to no music has scores like this: 7, 8, 5, 6, 7, 6, 8, 5, 7, 6. So first, calculate the average score for each group. You could use your calculator. You could also use Desmos.com to find the average. So if you're using Desmos, remember that there is a function called mean, MEAN, that's actually the function for calculating the average. But if you're using something like Excel, you'll need to use the word average as the function. And if you need help, let me know, and we can provide guidance on how to use online calculators or resources to calculate the average. Now, you might find that the average of one group is lower than the other. So maybe you find that the average for the music group is lower than for the silence group. This could suggest that under these conditions, listening to music could be linked to lower retention. But here's a critical question. Could something else be affecting the results? So for example, maybe the students in the control group had more comfortable study space, or were already strong students in that particular area of study. So in experiments, we always have to ask what other factors might be at play. So this is where we blend statistical thinking with some of our 7 grandfather teachings. So in this case, we have one of our teachings that's called wisdom or nabokawin. So the interpretation could be, to correctly interpret an idea or to listen with clarity and of sound mind. So even if our data shows a difference, we have to be cautious before drawing conclusions. Was the difference really due to music? Or might it be because of another variable that we didn't control? So here's your challenge. Consider 2 possible reasons why the groups might differ beyond just the music or lack of music. Jot those down and bring those to class. So remember, in both statistical research and in our Indigenous ways of knowing, we value every perspective. That it's not just about the numbers, but it's about understanding the whole picture. Now, in this next section, we're going to explore how experimental design strategies like blinding and the placebo effect help us to get even closer to a truth. But for now, review these ideas and think about how they might apply to other decisions you're already making in your life. So, let's say we found a difference between the 2 groups in our experiment. The group that studied in silence scored higher than the group that listened to music. But here's the big question. Is that difference big enough to matter? Or could it have happened just by chance? Now, in statistics, we say a result is significant if the difference between groups is too large to be explained by just random variation alone. It means there's strong evidence that something is going on. Now, we're not quite ready to calculate that yet in this course, but we are ready to think critically about it. So ask yourself, could there be another reason for the difference between these 2 groups? Sometimes we rely on our own experiences or stories from others. So for example, Someone might say, well, I study better with music because I always have. That's called anecdotal evidence, and it's based on personal experiences, and it can be powerful. But in statistics, it's not always enough to draw an overarching conclusion about other people. So, for example, you might say, well, I've always had this particular diet and I have this medical diagnosis. That doesn't necessarily mean that everybody that has that particular diet will have that same medical diagnosis. So one story doesn't necessarily prove or disprove a pattern. And in storytelling, we respect individual experiences, but we also look at a shared truth across our community. So to make our experiment stronger, researchers use techniques called direct control. And this means they hold certain variables constant across all groups. So let's go back to our study example. Maybe everyone studies the same material at the same time of day in the same space, and that way the only real difference would be the music. This helps us feel more confident that the results actually reflect the treatment and not something else. So remember, random assignment is another way to protect fairness because it means that we're assigning participants to groups in a way that's completely by chance. And this helps to ensure that both of the groups are similar from start, so that any difference that we see is more likely due to the treatment and not a hidden factor like age or prior knowledge or time of day. When we look through this lens, it really is in this idea that fairness is more than just the numbers and the math alone, but it's in how can we honor everyone's voice and give each person's experience an equal opportunity or equal footing. Sometimes people believe that a treatment in and of itself is actually going to change how they respond. And so that's why we use blinding, so that participants don't know which treatment they're actually getting. Blinding actually helps eliminate personal beliefs from affecting the results. Now, in some studies, even the researcher is blinded. When that's the case, we call that double blinding. The next term is called a placebo. Now, a placebo is a fake treatment, like a sugar pill or flavored water that has no active ingredients. But here's the amazing thing, that sometimes people actually feel better just because they believe that they're being treated. That's called the placebo effect, and it shows the power of belief and expectation. So good experiments often include both a control group and a placebo group, so that researchers can tell whether improvements come from the treatment itself or something else like that belief in that treatment. Now let's summarize what we've learned so far about well-designed experiments. So well-designed experiments, we control what we can, we assign fairly, we protect beliefs from influencing the results, and we stay open to the possibility that belief itself can shape an experience.